Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to general class. This episode is Sub-Element G7 Question Group C, and I'm your host, Ron Call, KE7CR. These questions are about transceiver designs, filters, oscillators, and digital signal processing. Let's get started. The first question asks, what circuit is used to select one of the sidebands from a balanced modulator? That's a filter circuit. Next, what output is produced by a balanced modulator? The answer is double sideband modulated RF. A balanced modulator mixes the RF with the carrier but suppresses the carrier frequency in the output, so it passes the upper and lower sidebands. The next question, what is one reason to use an impedance matching transformer at a transmitter output? That's so that you can present the desired impedance to the transmitter and the feed line. The most power is going to be transferred if the impedance of the transmitter matches the feed line, which matches the antenna. The next question, how is a product detector used? A detector is another word for a demodulator or a mixer circuit, and it's used in a single sideband receiver to extract the modulated signal. When receiving a single sideband signal, the product detector combines the received signal with a local oscillator signal, and it mixes those signals together, creating a new signal that contains the original voice or information. The demodulated signal can then be processed or filtered, converted into audio or data that we can receive and interpret. So the detector plays a critical role in separating the modulated signal from the carrier wave and allows us to retrieve the transmitted communication. Next question, which of the following is characteristic of a direct digital synthesizer, or DDS? As computers have become more capable, direct digital synthesis is being used to generate modulated frequency signals. So the answer to this question is a variable output frequency with the stability of a crystal oscillator. So it gives you a frequency stable signal, but you can have a variation of those frequencies. So the answer is a variable output frequency with the stability of a crystal oscillator. Next question, which of the following is an advantage of a digital signal processing, DSP, filter compared to an analog filter? Well, a wide range of filter bandwidths and shapes can be created digitally. That's not possible with an analog filter. The next question, what term specifies a filter's attenuation inside its passband? Now, any filter is going to decrease the signal strength. You're going to have some power loss in any filter circuit. So inside the passband, you're still going to have some attenuation of the signal. That's called insertion loss. The next question, which parameter affects receiver sensitivity? Well, the sensitivity of the receiver is affected by the input amplifier gain, also the demodulator stage bandwidth, also the input amplifier noise figure. So the answer is all of these choices are correct. The next question, what is the phase difference between the I and Q RF signals that software-defined radio, SDR, equipment uses for modulation and demodulation? I and Q signals are used as components of a quadrature signal. Quadrature, by definition, means 4 parts. 1/4 of a 360-degree wave is 90 degrees. So just memorize 90 degrees is the phase difference. The next question, what is an advantage of using I-Q modulation with software-defined radios, or SDRs? And a real advantage is that all types of modulation can be created with appropriate processing. Maybe not all types of modulation, but certainly a huge number of different types of modulation can be created with software-defined radio with I and Q modulation. The next question, which of these functions is performed by software in a software-defined radio, or SDR? First choice is filtering. That's true. The second choice is detection. That's true. That's the recovery of the signal from the carrier. The third choice is modulation, and that's also true. So the answer is all of these choices are correct. The next question says, what is the frequency above which a low-pass filter's output power is less than half the input power? That's called the cutoff frequency. The next question asks, what term specifies a filter's maximum ability to reject signals outside its passband? That's called ultimate rejection. And the last question, The bandwidth of a bandpass filter is measured between what two frequencies? It's measured between the upper and lower half-power frequencies. So the answer is upper and lower half-power. That's it for this question set. I know we didn't go into really much of the details of these answers. It's kind of one of these, if you want to go into that, look up some of these answers online or study the ARRL's books on basic radio. Hopefully this helped you to get started. Thanks for joining me for this episode, and look forward to you in the next episode. 73, this is KE7CR.